Hey there, my name is Brian Boyce, and today I'm going to be presenting my science presentation to you. My project is Which Liquid Works Best when Creating an Electric Current. I'm so happy that you could tune in. I hope that you enjoy this experience as much as I did. So let's just get straight into it. The purpose of this experiment is the purpose of this project is to determine, which liquid would be the great choice, which liquid would be the best choice when you're trying to create an electric current. My goal was to at least create close to the same voltage as a AA battery, which maintains around 1.5 volts. The three liquids that I tested were cranberry juice, vinegar, and then lemon juice. My hypothesis was that if I tested the three liquids, then lemon juice would do the best because when trying to create an electric current, according to the pH scale, it has a higher acidity than the other liquids. Cranberry juice has an acidic level of approximately 2.3 to 2.5. Vinegar, way up there with cranberry juice, 2.5. And then lemon juice has a very, very high acidic level as 2. So yeah, again, very high on the acidic level. My materials, pretty simple. Just need a long piece of thin iron rod, and the same thing for copper, long and thin. Pair of heavy bolt cutters, those are important. Zip ties, you're only going to need a few. You need a drill. You need a small plastic container. Make sure it's plastic because if it's metal or if it's like a metal can or something, or if the iron rods are touching the metal, it can affect your experiment and it's not going to work. And then, of course, your liquids, cranberry juice, lemon juice, vinegar, and then you want a voltmeter. Your procedure is going to be pretty simple for all three liquids. You're just going to collect all the materials needed, and then you're going to cut your iron and copper rods into 3 pieces about 3 inches long each. You're going to want to zip tie the iron rods together and zip tie the copper rods together tightly, very tight. That's important. And then you want to cut off all of the excess zip tie. You want to drill 2 tight holes into the lid of your small container. Make sure that they're only about a centimeter wide because you can always make them wider. But if they're too big, they're going to not hold your rods sturdy. Then you want to push your zip tie rods into the 2 holes and make sure that they're sturdy so that they'll stay in place. Then you want to fill your container with the cranberry juice, which is what I did first, and then put the lid of your container back on with the rods. You turn your voltmeter on and then touch the 2 ends of the voltmeter to the 2 ends of the copper and iron rods, and you record your data. You repeat this 10 times with the cranberry juice. Have an adult supervise, of course, to make sure everything goes safe. You record all data and then repeat steps 1 through 8 with each liquid, lemon, and vinegar. Here are the averages for each liquid. Cranberry juice had a very good average of 0.455, but as predicted, it did come in last place, unfortunately. Lemon juice, a close second to vinegar, with an average of 0.806. And then vinegar with a surprising average of 0.828. Here are the pictures of each of my liquids. So they may look the same, but if you can tell on the voltmeter, they have different volt measurements. So lemon juice up in the top left corner has a measurement of around 0.88. And then vinegar has an extraordinary amount of about 1 volt. But that was when it was first tested, and so we took the picture pretty quickly so that we took the picture, right when we started measuring with vinegar. So that wasn't an exact amount. It kind of settled down a little bit. And cranberry juice, as predicted, had, of course, a low amount of volt measurement. So here are the volt measurements for each trial. As you can see, again, vinegar had a very high amount, such as cranberry, which had, very low amounts in its trials. Lemon juice did come in pretty close, but not as high as vinegar's measurements. So my results. After testing the liquids 10 times each, of course, surprisingly, vinegar had the best outcome when I tried to create an electric current. It came to the average of 0.828 volts. This was surprising because although it's, very high in the acidic level, lemon juice has a higher acidic level than vinegar. And so that's why I was expecting it to do better. It was high in numbers, but lemon juice was a close second, maintaining around 0.086 volts. And as predicted, cranberry juice unfortunately came in last place with 0.445 volts. Vinegar kept the highest number in volts in comparison to the other liquids throughout each time. So, my conclusion. Since the vinegar had the best performance, of course, it is shown that it's the most ideal liquid to create when attempting to create an electric current. My hypothesis was proved false with this information, that lemon juice was going to do the best. The pH level, or the pH scale, potential of hydrogen, or measure of how basic or acidic the liquid being used is. The pH of vinegar caused this outcome. Cranberry juice had the least electric current, which was when it was being tested. The pH of cranberry is a bit high, but of course it did come in last place because of the acidity of lemon juice and vinegar. So the abstract, I just want to talk a little bit about, how this was a technique used by ancient man. And think just for a minute about how you use technology every day. This room is lit up. The screen that you're watching on is lit up. You might be charging it. You use technology every day. And it's not just technology, electricity, everything that you use, from your car to your house lights, to a ceiling fan, to anything at all, is pretty much all technology nowadays. So if ancient man can do this with the resources that they had, don't you think that it would be a lot easier for us with the resources that we have now to create this with a little tiny bit of our resources? I think that would be pretty easy. So the abstract is really based off of how this information can be really reliable and really reliable in a fatal emergency. And so why I say that is because if you were stuck somewhere, let's say like the desert, and you were on a camping trip, or you were on, a road trip, and you were out in the middle of nowhere, no houses to be seen, no cars passing by left or right, and your battery ran out, or your motor shut down, or something happened, you need a way to get out of there. You need a way to at least get to civilization. So you would try, if worst case scenario, to create a battery to get an electrical charge, or at least a spark to run up that motor again, run up your engine. And this would be a great way to do it. If you could create enough, that would be a great way to start up your engine and get it running again. Everything went great with the experiment. I think that there's nothing that really changed, and yeah, everything went safe, everything went well, and it was a really good experiment overall. So that's all for now. I thank you so much again for tuning in. I think that this experiment, I'm really proud of it, and I think that I did great. I hope that you enjoyed. I hope that it was, worth your while. And thank you again. I can't thank you enough, because it was really, 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 it was really an amazing adventure and journey for me. And I hope that presenting it to you and sharing it with you was as well. You have a great rest of your day, night, whatever time you're watching this. And yeah, stay safe.